So as far as I know, because I've read your bio and, again, I've been really researching you. You're currently, and correct me if I'm wrong, you're working on exploring the empty spaces in the cosmos and in the universe and so on. Um, can you walk me through that? Because I'm so interested in the process of people like you, professionals in this area, in their day-to-day routines, and how they extract the information that we at some point receive as the end user.
Yeah, exactly. So I'm absolutely fascinated by these objects in the universe called cosmic voids. These are the
Wow.
largest empty regions in the universe, the smallest ones. So the smallest ones are 20 million light years across on a
Wow.
side. They actually fill up the volume of the universe. Anywhere between 80 and 90% of the volume of the universe is in a void, and the voids contain almost absolutely nothing. I got interested in voids after my PhD. I spent 6 years working on my PhD. And shortly before graduation, I was searching around, and one of the people I had worked with early in my graduate career, Ben Wandelt, who had suggested this idea that I worked on with my advisor about interacting dark matter and dark energy.
Mhm.
Since that, we had worked together for about a year, and then he left for the University of Paris. And I stayed in touch with him, and I mentioned I was graduating, and he said, "Hey, I have a position open. Would you be interested?" And I said yes. And so I didn't even have to apply to a whole bunch of jobs. I got, just straight tracked to working with Ben. Moved to Paris. We started working on voids together. He had this interesting idea, and I took it, and we wrote a bunch of papers. And now the work is being largely sustained by a large number of collaborators, like Lice Pisani, Nico Haumaus. Ben is still active. I'm still active. There are a number of people that are working on this topic. And the basic idea is to look out at the universe, which we
Mhm.
do all the time. We have galaxy surveys. We're mapping large portions of the universe, the locations of galaxies in the
Mhm.
universe, and paying attention to where the galaxies aren't, and developing tools and methods for mapping these regions, for measuring them, for locating them in our surveys. And then we have, once we have these list of voids, their locations, their
Mhm.
extents, we can do all sorts of things. One is we can examine voids as an interesting facet of nature. This is a thing found in nature
Mhm.
that we can study. They have interesting properties. And so there's one line of research that is all about just investigating the nature of voids at a fundamental level. There's another avenue of void research, which is the properties of voids, like the number of voids, their sizes, how they evolve with time, is intimately connected to burning questions that we have in cosmology, like the nature of dark matter and the nature of dark energy, the history and the future of the universe. All that information is contained in the properties of the voids, which is a direction that cosmologists have not really looked in previous to this research. And so that aim is to study the voids, extract their properties, and then connect those properties to things like the nature of dark matter and dark energy.
Wow. Wow. This sounds so interesting. Like, is there a specific, and I know this is a very simplistic way to ask this question, but in general, how are the voids being formed? Because we know about entropy, we know about the physical, the connection between particles in cosmos and so on and so forth. Like, is the formation of voids, just something that is, something that happens, just a coincidence of different processes. So if there is there like a specific reason to for them to be formed?
Yeah, so the voids don't just appear, they are a consequence
Mm-hmm.
of natural processes that happen in the universe, which is what allows us to connect them to fundamental properties of the universe.
Mm-hmm.
What we find at the very largest scales, when we zoom out, when we do our biggest surveys, we're looking at such enormous volumes that galaxies, entire galaxies, are just tiny, tiny points of light. When we're
Wow.
looking at that kind of scale,
Wow.
this is where we see a structure appear. We call it the cosmic web. The cosmic web is made of dense nodes, clusters of galaxies, long, thin filaments, like highways of galaxies. We see these broad walls made of galaxies. And then in between all those structures are the cosmic voids. And so this cosmic web has evolved over the past 13 billion years. 13 billion years ago, our universe was much more uniform, much more even. The density of matter throughout the universe was pretty much the same all everywhere, but there were tiny little differences. And those tiny little random differences eventually grew up. Because if you have a tiny little difference with just a little bit more
Mm-hmm.
energy, a little random pocket of the universe with a little bit more density, it will have a little bit more gravity.
Mm-hmm.
And that slightly stronger gravity will cause it to pull on its surroundings. It will accumulate matter, which gives it even more density, which gives it even more gravity, which allows it to pull even further away.
Oh.
And so we see over hundreds of millions of years this cosmic web emerging, where matter groups itself together from small to big. The galaxies emerge, groups emerge, clusters emerge, and then all that matter has to come from somewhere, and it comes from the rest of the universe. And so matter gets evacuated from the voids.
Wow. That's a whole another aspect that, I haven't personally kept attention on. Um, for you, what's the most exciting resultant outcome that you can generate from your research on this specific matter? Like, what's the most interesting thing that you think you can get extract from it?
One of the most fascinating things that we've discovered about cosmic voids is that they all share common properties. And in fact, all voids are pretty much the same throughout the universe. They have certain universal properties. There are small voids, there are big voids. There are voids that have these dense walls surrounding them, almost boxing them in. And then there are voids that just smoothly transition into populations of galaxies. And at first glance, you look at all these voids with all these different shapes and sizes and properties, but we were able to discover some very universal features among voids. And that if you actually take a small void and you find a random small void, and if you were to stretch it out,
Mm-hmm.
you would actually end up smoothing things out and you would make it look like a big void. And if you were to take a big void and scrunch it down, you would actually recover the properties of a small void. So we found this universal connection between all the voids. We actually learned that voids are fractal in a sense, that they can be rescaled and maintain their properties. And this universal behavior of voids has allowed us to unlock so much knowledge about them, because it means we can do a survey of the universe, we can gather a lot of voids, and we can apply those properties throughout the universe.